In this circuit, the switch was initially at position X, this switch, and at t is equal to 0, this is connected to position Y. So we need to find the current I through the inductor, 0.5 Henry. Now when initially before t0 or at t0 I would say, the current, the inductor was at steady state. This was a closed circuit, inductor was short circuit, so the current through the inductor I was -5, because this current source would go that way, the current, this one would have been shorted out, so the current is 5 ampere. Now when this one is connected, we have a circuit like that. When the switch goes to position Y, we have like that, and that's the inductor, 0.5 Henry. Now what we have here, if I write the KVL, 12 Ri plus 1 over L I dt. So that's the drop across inductor. The current through an inductor cannot change instantaneously, we know that. So this is becoming di dt plus IL. So we can see here from this one, the final current will be, finally the inductor will again be short circuited, and the final current will be of course defined by the voltage source and the resistance, so that will be 3 ampere. So if we say I final, that will be 3 ampere. So the inductor current equation will consist of two parts. One is the transient current, which we can say this is IL, so let's call it, yeah, this is IL. So this one is say I0, just as an expression, and IF. Now this one we know from this differential equation, so this current will become I, can say transient, e to the power minus t over L over R, because time constant is L over R, and this part remains as IF. So this is IT e to the power minus R t over L plus IF. Now at t is equal to 0, the time is at t is equal to 0, IL is -5. So -5 at t is equal to 0, this part becomes 1. So this is IT plus IF is 1, is -5. And we have another boundary condition, which is t is equal to infinity, and that IL becomes 3. So we can write 3 here, and when t is equal to infinity, t tends to infinity, this part becomes 0, because this is minus RT, plus RTL, so this is 1 over infinity, so this part becomes 0. So we have only the other component, that's of course the final component. We can even write it from the differential equation. We know that IF is, by physically looking at the circuit, we know that IF is 3. So it comes from mathematics as well as looking physically. So IT is becoming, from plugging in here, we have -5 here is equal to IT plus 3 here. So IT is becoming -8. So our final equation is becoming IL is -8 e to the power minus RT over L plus 3. And we can see now, looking at this equation, when t is equal to 0, if we plug in here, this is our final equation, we get IL is equal to minus 8 plus 3, which is minus 5, and when t is equal to infinity, we have IL is equal to, this one goes 0, so this is becoming 3. So this is how the current will look like. The wave shape starts at minus 8, settles at 3. So if this is 3 and if this is 8, so this is decaying and finally settling there. Initially it was minus 8 and then it is 3. Finally it's 3.